Hello everyone, I am Professor A.R.Shinde. We'll see now the next part of the compression members chapter, that is problems related to the compression members. Okay, so we'll proceed to it. So yeah, okay. A column consisting of SC 140 about 33.3 kg per meter has an unsupported length of 4 meter. It is effectively held in position and restrained against rotation at one end and the other end restrained against rotation but not held in position. Determine the axial load this column can carry if the steel conforms to IS 220. Okay, so here they have given us the column section, that is SC 140, and they have given us the unsupported length, that is capital L, that is they have given us 4 meter. Okay, and then they have given us the effective length conditions. Okay, condition. Okay, so what is the condition? Effectively held in position and restrained against rotation at one end, and at the other end restrained against rotation but not held in position. So this is the condition for the effective length, and then they have given us the axial load this column can carry if the steel conforms to IS 226-1975. So the steel property has to be taken from the IS code 226-1975. So steel properties that is sigma that is yield stress, Fy is equal to 250 is taken from 226 IS 226 1975 as per they have given in the question. Okay, so from IS 226 our yield stress of the steel section is 250 Newton per mm². So for now go for the compression member design for SC 140. So we'll look for the SC 140 member in the steel table. Okay, we'll look in the steel table. So we'll get the properties for the steel member SC 140, that is area is equal to 4.24 into 10 raised to 3 mm², comma Rex equal to 58.5 58.9 mm, Ry is equal to 32.1 mm. Then effective length of the column. So effective length of the column L is equal to, from the condition, so for the condition effectively held in position and restrained against rotation at one end and at the other end restrained against rotation but not held in position, that condition will have effective length small l is equal to 1.2 into capital L as per the table 5.2, as we have seen it in the previous lecture. Okay, you can see it in that lecture, that video. Okay, so L is equal to 1.2 into 4, that is 4.8 meter is our effective length. Maximum slenderness ratio sigma max is equal to L upon R minimum is equal to 4.8 into 100 upon 3.21 is equal to 149.53. Now from now, so from the table 5.1, by interpolation for sigma AC at lambda is equal to 140 and 150. So for this lambda max value, we have to go for the table 5.1. Okay, for the interpolation to find the value of sigma AC, as we have studied it in previous video or previous lecture. So we'll go in that table 5.1. So this is table 5.1. Our value of lambda is our value for the lambda is between 114 and 153, that is in between 140 and 150. So this is the value 140 and 150 in between this, and our Fy is 250. Here Fy is 250. So 140 and 150, our value is 140 to 150, and here is the 250, 51 and 45. So by the interpolation we can go by 51. Interpolation formula is from derived from mathematical lesson, or it is mathematical formula. Okay, for that. Okay, so here how can we interpolate it? 51 minus 45 into 149 minus 149.53 minus 140 upon 150 minus 140. This is the formula for that. 51 minus 45 into 149.53 minus 140 upon 150 minus 140 is equal to 45.28 MPa. This is the sigma AC value in Newton per mm square. So allowable axial compressive load in kilonewton we have to derive, that is 145.28 Newton per mm square. We have to take it in kilonewton into 4.25 into 10 raised to 3, as here the value is in mm square. We have to take it in mm square only. Okay, so that strength or compressive load is 191.987 kilo Newton. So this is the compressive load value we have derived from the 5.1 table, okay, by the interpolation. So now we'll go for the next problem. Okay, next problem 5.2. A single angle strut ISA to 50 by 50 by 50 by 50 by 6 of a roof truss is 1.06 meter long. It is connected by one rivet at each end. Determine the safe load this strut can carry. Okay, so now we'll see this problem. So here they have given us the section 50 by ISA 50 by 50 by 6. Then the roof truss is 1.06 meter long. It is connected by one rivet at each end and determine the safe load this strut can carry. Okay, so we have to calculate again the permissible load or permissible axial load or strength of the member. Okay, so for ISA 50 by 50 by 6 from steel table, we get the properties of that section. A is equal to 5.68 centimeter square. Then R minimum, that is RV, is equal to 0.96 centimeter. Effective length, that is 1.06 meter. Okay, here they have given us the roof truss is 1.06 meter long. Okay, so they have not given us the condition. So that means that is there is this is the effective length. Okay, so we no need to write L is equal to from any load conditions. Sorry, end conditions. Okay, so maximum slenderness ratio lambda max is equal to 1.06, that is L upon R minimum. 1.06 into, this is in meter, this is in centimeter, so convert it in meter, sorry, centimeter. So we get 110.42. Okay, so this is not greater than 180, so our check is satisfied. Then assuming this still conforms to, so here they have not given us the property for sigma, Fy or steel condition, steel yield stress property, so we can take it from the IS 226 1975. Yield stress is equal to 240 Newton per mm square from table 5.1 by interpolation. So we have got the lambda max value 11042 and the yield stress, that is Fy is 250 Newton per mm square. So here 110.53 and 250. So it is between 110 and 120. Okay, 110 and, sorry, what is the value? Yes, 110 and 120. So here, how is the calculation we can do? How is the interpolation now? 72 minus 64 into 110.42 minus 110 upon 120 minus 110. Okay, 72 minus 64 into 0. That is 110.42 minus 110 upon 120 minus 110. That is 71.664 MPa, that is Newton per mm square. So this value is so permissible axial compressive stress for discontinuous single angle strut connected by single rivets at one end is equal to 0.8 sigma AC. So here this is the condition for the single angle strut connected by single angle rivets, as we have seen in the table 5.3 in the compression member introduction. So for that the permissible stress is taken as 0.8 sigma AC. So we have to multiply sigma AC by 0.8. It will be 57.33 MPa. So multiply it with the area, we'll get 32.56 kilo Newton. Okay. So next we'll see the next problem. Okay, so we'll see the next problem, that is 5.3. Okay, a double angle discontinuous strut consists of two ISA 60 40 6 mm thick with two rivets, with longer legs back to back connected to opposite sides of a gusset plate 10 mm thick with two rivets. The length of strut between the center to center of intersection is 4 meter. Assuming tacking rivets have been provided along the length, determine the safe load carrying capacity of this section if the yield stress for steel is equal to 250 MPa. So here from the steel table, they have given us this steel section, that is 60 40 6 mm thick. So A is equal to 5.65 centimeter square, Rx is 1.88, Cy is 1.0 centimeter, Iy 7.7 centimeter raised to 4. So here we have to take Iy again, because we have to take out the R minimum. So they have not given us the R minimum. So from Iy we will again take out, we'll again solve one Iy, and from that Iy we'll take out our Ry, and from that Ry and Rx we'll take out our R minimum. So here first Rx is 1.88 centimeter, same as for single angle. So it is given. Okay. Now then Iy, what is Iy? Iy is equal to 2 into, as they have given double angle section 2, I say, so 2 into 7, that is Iy, 2 into Iy plus 2 into area into 1 plus 0.5 1.0.5 square. One is Cy plus 0.5 centimeter square is equal to 39.425 centimeter raised to 4. Then Ry is equal to under root Iy upon A is the formula. So Iy is 39.425 upon 2 ISA. So 2 into 565 is equal to 1.87 centimeter. Therefore, the minimum radius of gyration R minimum is equal to 1.87. So this is the figure. So this is the figure. Now effective length of the strut. So effective length of the strut, we again have to go for the condition, that is for the length condition. So here we will again go for the condition, but there is no condition like for this problem. Okay, so here we have to take it as 0.8 into 0.85 into 4. Okay, so 0.8 into 4 is the length we have to take here for this problem from table point 5.3, as we have seen that concept or seen that conditions in the previous video of the introduction of compression member. So from that condition. Okay, so maximum slenderness ratio is equal to lambda is equal to L upon R minimum is equal to 3.4 into 100 upon 1.87, that is 181.8, that is greater than 180. Okay, so such a strut is used to carry compressive load due to wind earthquake forces only since LR 180. That is, that forces or that strut is used to carry earthquake and wind forces, so it is greater than 180 they have considered. Then from that condition 181.8 and from 250 Fy, again interpolation is carried out from the table 5.1. What is 181.53? So it is 180, and between 180 and 190 and 33 to 30, that is 33 minus 33 minus 30 into 183 point 183 point, how much that was, 183 point, sorry, what was the 181.8 minus 180 upon 190 minus 180, that is 10. So 39 33 minus 33 minus 30 in bracket, that is into 181.8 minus 180 upon 190 minus 180 is equal to 32.46 MPa. So their safe load is equal to 2 into 32.46 upon 1000 into area, that is 5.65 into 100 is equal to 36.67 is the safe load. 2 is used for the that is used as 2 ISA or double angle. So this is the problem, and next problem you can solve for your practice. Okay, thank you.